Okay, in this video, I'm going to go over the day one of the practice with probability. Now, our focus here is just on section 14.2. So when I don't think this is right. Okay, so when you read this problem, I should go back and highlight one very important thing. What is the likelihood? The second you hear that, you should be thinking probability. So I kind of grouped these people in three different groups. I grouped them as the Tom, Jane, Phil group, and then the all other group. So my denominator, So the denominator for this is going to be 15, choose 3. Okay, of that, from the Tom, Jane, Phil group, I'm going to choose all 3. And from the all other group, I'm going to choose 0. Okay, that's the probability that will include all 3 of them. Okay, let me change. What's the probability it's going to include none of them? So then what's going to happen is I'm going to have a 3 choose none times the 12 choose 3 all over the 15 choose 3. So that's the second answer right here. Okay, here's the first one. I'll tie the pink to it. Okay, include at least one of them. Okay, so that's something to think about. At least one means it could include 1, it could include 2, it could include 3. So I'm going to make this a little bigger. Okay, if it's going to include one of them, from my group of Tom, Jane, and Phil, let me just change the color so it looks different. So it's going to be 3 choose 1, and then my other group is 12 choose 2 all over 15 choose 3. So that's if it includes one of them. So, or it could include 2 of them. Notice how I use the word or. This is an or problem. If I included 2 of them, then it would be 3 choose 2 and 12 choose 1 all over 15 choose 3. And then let me see if I can make this bigger this way. Yes, I can. Let me get rid of this. So that's if there was exactly 2 of them. But then I had the possibility that there's 3 of them, because that's also at least 1. So it's going to be 3 choose 3 times 12 choose 0 over 15 choose 3. Okay? As opposed to exactly 2 of them. So exactly 2 of them is going to be this. So let me see if I can just pick up this and say copy and say put that right there. Okay, that's exactly 2. All right? So hopefully that helped. And the key is the word likelihood means it is probability. Okay, moving on to question 5. There are 20 seniors, 30 juniors, and 10 sophomores eligible for dress down passes. You'll be giving out 10 dress down passes. From those 10 passes, 2 must go to sophomores, 3 must go to juniors, and the remaining 5 must be given to the seniors. How many ways could this be done? So if you're going to do exactly what they just said, how many ways can you do it? Well, let's see. I have 10 passes. 2 are going to go to sophomores, so I have 10 choose 2. Then I have 3 must be given to juniors times, I have 30 juniors, 30 choose 3 times, and the 5 must be given to seniors, and I have 20 seniors, choose 5. Now notice that it says, how many ways can this be done? This is not a probability. Okay, so then it says, if you could instead give the passes to whomever you like, what is the likelihood that no sophomore would be chosen? So how about, what is the likelihood that for 10 passes, 10 sophomores are chosen? Okay, wouldn't it be 1 minus that? So you can do the 1 minus. So 1 minus, all the sophomores get them. That would be the likelihood that no sophomores would be chosen. The 1 minus that all sophomores are chosen. Okay, so that's doing the complement. Okay, going down, we have cards. So let's look at these cards. You draw 3 playing cards from a standard deck of 52 cards. How many different 3-card selections are there? Okay, this is not a probability, but you're selecting 3 cards from the deck. So you're going to say the number of possibilities. I have 52 cards, and I'm going to choose 3. That's the number of possibilities. Then you can put that in your calculator. Okay, what is the probability that all 3 cards are aces? So all 3 are aces. Well, there are 4 aces. The aces are all here. So you can say, and also it's probability. So that's another thing, focus on that. So you need a denominator, and your denominator is 52, choose 3. Okay, your numerator is going to be, I have 4 cards that are aces, I'm going to choose all 3 to be aces. And that would be your answer. And then you put that in your calculator. Okay, now they do a blending. What's the probability? So again, you're going to have your fraction, that 2 of the cards are spades and 1 card is a diamond. Okay, so once again, your denominator is still going to be 52, choose 3 cards. Remember, order does not matter. Then if you know that 2 of the cards are a spade, well, the spades, let me erase this, the spades are all of these, right? There are 13 of them. So out of that hand, 13, I'm going to choose 2 times, and I need 1 card to be a diamond. So let me erase the spades, and here come the diamonds. So I also have 13 diamonds. So now I'm going to say 13, choose 1. So what you should be cognizant of is the fact that 2 plus 1 gives me 3. Okay? And you're dealing with a deck of 52 cards. All right, so then that brings us down to D. D says, what's the probability that 1 card is a spade, 1 card is a diamond, and 1 card is a heart? Since I have 3 demarcations, I'm going to have 3 items in my numerator. So my denominator is still going to be 52, choose 3, but then this is going to be 13, choose 1, 13, choose 1, and 13, choose 1 for each of those suits. Okay, what's the probability that none of the cards are black? Well, isn't that 1 minus the probability that they're all black? So that's going to be, there are 52 cards, excuse me, there are 26 black cards, and we're going to choose all 26, and my denominator was going to be 52, choose 3. Okay, those are all the card problems. Then we go to a flip the coin problem. You flip a coin 5 times. What's the probability? Okay, so you're dealing with probability again. It's a fraction. That all 5 flips show as heads. Okay, each flip is 1/2. You have half tails, half heads. Times 1/2, times 1/2, times 1/2. That's your 4th coin, or the 4th time, times 1/2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the chance that you're going to get 5 heads in a row is 1 out of 32. Okay, let's keep going. 10 slips of paper numbered from 1 to 10 are put into a hat, and you pull out 2. Okay, the first slip is not returned to the hat when you pick the second slip. Still an and. Okay, both numbers are even. Okay, the first time you pick, you have 5 chances of getting an even out of the 10 that you have. Now you did pick an even, so your next time there's only 4 evens to choose from, and you didn't put the even back initially, so you only have 9 possibilities from which to choose. So that's 20 over 90. Okay, both numbers are odd. Same idea, same reasoning, same answer. You have 5 chances of getting an odd out of the 10. You get an odd, you don't put it back. You then have 4 chances of the 9 remaining of getting an odd. So once again, it's 20 over 90 for a different reason. The first number is a 5 or a 6. Okay, the chance of getting a 5 is 1 over 10. The chance, and that's a 10 out of 16. I just make that look better. Plus the chance of getting a 6 is 1 out of 10. So this is an OR problem. Now there's no overlap, so I have nothing to subtract. And that's going to be 2 out of 20. Excuse me, 2 out of 10. Lost my head there. Which can reduce to 1 over 5 if we really wanted to be reducing. Okay, next thing. What's the chance that both numbers are greater than 7? So to be greater than 7, it has to be 8, 9, or 10. So the first number, let's say the first number is an 8. You have 3 out of 10 chances of that happening. So let's say you pick the 8. The second time there's only 2 numbers remaining, 9 and 10. But now there is 1 fewer slip of paper in there. So you're going to get 6 over 90. Okay? Okay, let's move on to the problems with the dice. Using the 36 possible outcomes from rolling a pair of dice, find the following probabilities. So again, probabilities. When you read it, you've got to read it like this so that you are attuned to when it's probabilities and when it's just number of occurrences. Okay, first off, you got 36 possible outcomes. They told you that. That's your denominator. So a sum less than 7. So look what I'm going to do. I'm going to go right down the middle here, this diagonal, and those are all sums equal to 7. So everything less is above that. So count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It looks like there's 15 that will give me a sum less than 7. So that's going to be 15 over the 36. Okay, a sum that is not 10. Now, I think the easiest way to do that is to figure out how many sums are 10. So let's look for the 10 row. It's right here. Okay, so there are 3 sums that are 10. So why don't you do 1 minus 3 over 36, and you will get an answer for that. So what are you going to get? Looks like you're going to get 33 over 36 by using complements. Okay, at least 1 6. Excuse me, at least 1 3. Let me erase this. That means you can get 1 3, or you can get 2 3s. At least 1 3 gives us those options. Looking here, I'm going down this row. That is where the first die is a 3. Okay, then this column is where the second die is a 3. So you're not going to do any double counting. So now figure out how much you have left. So let me see. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So there are, well, I guess it'd be easier, okay? I could say there's 25 out of 36, or I could have done the complement. So at least 1, 3, okay, so at least 1, 3, count what I haven't highlighted. Let's do this correctly. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The key is do not double count. So I'm not going to count the one that has 2 3s twice. So again, count that horizontal row, 1, 2, 3, 4, 5, 6, and then count vertically 1, 2, 3, 4, 5, not 6. So that's going to be 11 out of 36. Okay, how about a sum of 3 or 5? Okay, that is your tip-off that it is going to be a situation where you're going to add and then subtract the intersection, but there is no intersection. So a sum of 3. How many ways can you get a sum of 3? So let me erase what I have here. Get rid of all of this. Good, good, good. Okay, so let's look for a sum of 3. It looks like these are the only ways I can get a sum of 3. So that's going to be, what, 2 right here. So that's going to be 2 out of 36. How many ways can you get the plus? How many ways can you get a 5? So 5 looks to me like it's right down here. Whoops. Get rid of that box. So if I go right down here, I have 1. So sorry. Try that again. I have 1, 2, 3, 4 ways to get a sum of 5. Okay, so I'm going to add that to it because it's an OR problem. And that's going to give me 6 out of 36. Okay, and the last thing we're going to do is do this table. Tables are very, very helpful. So it says use a table to find the probability. So again, probability. I'm going to give a fraction for an answer of selecting a hot dog and a water. Okay, so it has to be a hot dog and a water. So let's look. There's an intersection between hot dog and water right here at 62. So it's going to be 62 over the total of 400 since it's a probability. Okay, a pizza or a soda. Okay, so what we're going to do with that is we're going to first go and figure out pizzas. So what's your probability of getting a pizza? It's this row, which is 182. So that's 182 over the 400. 4 is plus what's the probability of getting a soda? And why don't I change my highlighter to pink? Here's the probability of getting a soda, and that's going to be 200 over 400. But I have an overlap, and the overlap is 120. So I'm now going to subtract 120 over 400. Okay, so that's what you're going to get. So you're going to do that math. So 182, I have 182, plus I have a 200, and then I'm going to subtract away a 120, and that gives me, for that OR problem, 262 over 400. 262 over 400. Look at the next one. Same idea. A soda or a water. Now I said same idea, but is there any overlap? So here's where the soda is, right? There's 200 of those. So that's going to be 200 over the 400. Or a water. Here's where the water is. There's 140 of those. Plus 140 over 400. There's no overlap. It's either soda or water. There's nothing like that's a blend of soda and water. So just add those two together and you're going to get 340 over 400. So what's your probability, the very last question, of getting not a hot dog? So I think the easiest way to do this is with the complement. So what's the chance of getting a hot dog? 158 out of 400. So therefore, not a hot dog is 1 minus 158 over 400. All right, and that concludes the practice on the 4.2. So I would say go back and do that. There's more work in here, and that's going to deal with your algebra. So we can go ahead and start doing that now as well. Here. So I think I'm just going to call it a day for this video, and then I'll put the other algebra perhaps on another video. Okay? So I'm going to stop here with just the review of the probability.